So far, we have been looking at simple equations with one unknown. But what if we have two unknowns in two equations? These equations can be solved at the same time. Hence, they are called simultaneous equations. Simultaneous equations can be solved algebraically by the elimination method or the substitution method. In the elimination method, as the name suggests, we eliminate an unknown which has numerically equal coefficients in both equations. For example, Richard is X years old and his father Raymond is Y years old. The sum of their ages is 69 years. The difference between their ages is 27. Determine Richard and Raymond's ages. The equation for the sum of their ages is y plus x equals 69. And for the second equation, y minus x equals 27. Since in both equations the two variables have the same coefficient numerically, we choose either one to eliminate. In this case, we will eliminate x. Since they are the same numerically but have opposite signs, we add both equations. When we do, we get 2y equals 96. Of course, this makes y equal to 48. Now that we have a value for y, we can now substitute 48 for y in any equation. So if we choose equation 1, then x plus 48 equals 69. So x would be equal to 21. Therefore, Richard is 21 years old and Raymond is 48 years old. When the coefficients of an unknown are numerically equal in both equations and also have the same signs, the equations are subtracted. Let us look at the two equations. 4x minus y equals 13 and 3x minus y equals 9. Since in both equations the coefficient of y is negative 1, we subtract the equations to eliminate the y. When we do this, we now have a value for x, which is 4. We can now substitute 4 for x in an equation. Let's use equation 1. Since we are substituting 4 for x, we end up with 16 minus y equals 13. And hence, y is equal to 3. So our solutions are x equals 4 and y equals 3. Sometimes we are given a pair of equations in which none of the coefficients are numerically equal. In this case, we multiply one or both equations by constants to form new equations with equally numerical coefficients for one of the unknowns. Let us look at the equations 4x minus 3y equals 11 and 3x minus 2y equals 8. Since none of the coefficients are numerically equal, we choose a variable to eliminate. Let us eliminate the x. So we multiply equation 1 by 3 and equation 2 by 4. Our new equations are 12x minus 9y equals 33 and 12x minus 8y equals 32. Since we now have coefficients that are equal and have the same sign, we subtract. We now have negative y being equal to 1. But we still have to solve for y. In order to completely solve for y, we divide negative y and 1 by negative 1, since the coefficient of y in this case is negative 1. So now y equals negative 1. Now that we have a value for y, we substitute negative 1 for y in an equation. Let's use equation 2 this time. When we substitute negative 1, we get 3x plus 2 equals 8. And therefore, x equals 2. So the solutions are x equals 2 and y equals negative 1. To use the substitution method to solve a pair of simultaneous linear equations, rearrange one of the equations to make one of the variables the subject. To identify which equation to rearrange, select the one which has one variable with a coefficient of 1 or negative 1. For instance, in the equations 2x minus y equals 8 and 3x minus y equals 13, in this case, we can rearrange any of the two equations to make y the subject. But let's choose equation 1. Therefore, y equals 2x minus 8. Since y is now equal to 2x minus 8, it means that anywhere we see y in equation 2, we replace it with 2x minus 8. This gives 3x minus 2x minus 8 equals 13. This is simplified to x plus 8 equals 13. Our solution is therefore 5. We next substitute 5 for x in equation 3. So y equals 2 times 5 minus 8, which is 2. Our solutions are therefore x equals 5 and y equals 2. Simultaneous equations can also be solved graphically. We draw two lines using the same axes. The coordinates of the points of intersection of the two lines are the solutions to the equations. This will be done in another lesson, but we first need to learn how to draw simple linear graphs.